Hello and welcome to The Space Above Us. Episode 40, Apollo 12 Part 2, A Long Step for Pete. Last time, we talked about the start of humanity's second journey to the lunar surface, Apollo 12. Pete Conrad, Dick Gordon, and Alan Bean set off in dramatic fashion in November of 1969 when their launch vehicle was struck by lightning not once, but twice. Some quick thinking on the ground and some quick action on the vehicle saved the mission, and Yankee Clipper and Intrepid were soon on their way to the moon. We left Commander Pete Conrad and LMP Alan Bean in orbit around the moon, making preparations for landing. As I touched on last time, precision was the name of the game for this landing. Future missions were eyeing scientifically interesting but tricky landing sites, so the ability to land precisely was going to be important. With that in mind, Pete Conrad's goal was to land Intrepid near a known landmark, the defunct unmanned probe Surveyor 3. A number of minor tweaks were made to the build-up to the landing in order to increase the chances of a successful pinpoint landing. First, by using data collected from Apollo 8, 10, and 11, as well as unmanned missions, scientists were able to build a more accurate map of lunar mass concentrations. These unevenly distributed lumps of denser rock created a non-uniform gravitational field that would tug at the orbit of anything flying around the moon. The effect wasn't the strongest, but it built up over time and could really mess with an orbit. With that in mind, Yankee Clipper placed them in an initial orbit that was not ideal to start with, but would be massaged by the uneven gravitational field into the correct orbit by the time the LEM undocked. When that undocking occurred, the vehicle stack would be oriented vertically relative to the surface of the moon, so that any additional velocity imparted to the LEM would be in the radial direction. This would make the least impact to the orbit, as it could be addressed in the upcoming descent orbit insertion burn. Additionally, Yankee Clipper used its RCS thrusters to back away from Intrepid rather than the other way around. By treating the undocking so delicately, orbital perturbations were minimized. Another factor working in favor of the Apollo 12 crew was that their landing site was considerably further west than Apollo 11's. From acquisition of signal as it flew around the moon's eastern limb to power descent initiation, the Eagle only had 17 minutes. Intrepid would have 37 minutes, giving the ground an additional 20 minutes to get one last state vector relayed up to the crew. Lastly, the crew started in the face-up position rather than face-down. On 11, the crew had started with their feet flying forwards and their faces pointing down towards the surface. This allowed them to spot the passage of known landmarks and estimate any downrange error, but it also forced them to perform a 180-degree yaw while the descent propulsion system was firing, which was tricky on its own, could interfere with communications, and prevents the landing radar from getting an early look at the surface. 110 hours, 20 minutes, and 38 seconds after lifting off from Florida, Pete Conrad pressed Pro to proceed, and the computer fired up the descent propulsion system. Just like before, the engine eased into it, firing for nearly 30 seconds at a low thrust level to get a handle on the precise center of gravity of the vehicle. With nothing out the window but the blackness of space, the crew trusted their vehicle and monitored their instruments. During this phase of the descent, the ground relayed up that final state vector, and Alan Bean entered it into the computer, correcting for a 4,200-foot error. One happy side effect of starting with the back of the LEM facing the moon is that the landing radar locked onto the surface far earlier than anyone expected, allowing the crew to have confidence in their guidance numbers. 6 minutes into the descent, the computer entered P64 and Intrepid began to pitch forward. The crew were still leaning back from vertical, but could now glimpse the surface outside their windows. At first glance, everything seemed wrong. The wider field of view and additional detail of the real thing, as compared to the simulator, was momentarily disorienting. But Conrad focused on the view in the landing point designator, and suddenly everything fell into place. The view was exactly what he expected, and Intrepid was on course. Surveyor's crater could be seen ahead. While Bean called out velocity, altitude, and fuel status, Conrad used its hand controller and LPD to tweak the landing site. First to the right, then downrange again, right, back, right. Each of the 7 moves made a slight change to the automatic landing point. At first the point was moved by 400 feet at a time, but as Intrepid approached the ground, each successive adjustment was smaller. The end effect was to swing the approach path off to the right a bit, and then once in manual mode, back to the left, and a bit further downrange to avoid landing in the small crater containing their robotic target. At an altitude of 368 feet and a vertical descent rate of 8.8 feet per second, Pete Conrad took manual control, and the LEM entered Program 66, irrevocably committing the commander to a manual landing. Bean called out the final descent as Conrad focused on the landing. 350 feet, coming down at 4. 10% fuel. 257 feet, coming down at 5. Bean reminds Conrad, "Come on down, Pete." Conrad responds, "Okay." 180 feet, 9% fuel. 8% fuel, 96 feet, coming down at 6. Dust begins to grow thicker and thicker out the window. 80 feet, 70 feet, 60 feet, coming down at 3. 50 feet. Ground control interjects low level. Conrad has less than 2 minutes of fuel remaining. At 40 feet, the dust is so thick that the view out the window is totally obscured. The crew knew to expect some dust thanks to the reports from Neil Armstrong and Buzz Aldrin, but not like this. For the 11 crew, the dust was compared to fog. It obscured some features, but the ground could still be seen out the window. For the Intrepid, the view was just completely gone. Conrad had no choice but to focus his attention inside on his instruments. He checked his cross-pointer display, which indicates his horizontal velocity, but it read 0 feet per second. With no view out the window to reference, he couldn't check for himself and found the reading suspicious. He wasted valuable mental bandwidth trying to get a good view out the window since he didn't want to trust the instrument. Later analysis showed it was correct, though. His final descent was so perfectly vertical that the cross-pointer didn't even register any horizontal movement. 30 feet, coming down at 2. Mission control radios 30 seconds. 18 feet, down at 2. Contact light. Engine shutdown. Intrepid drops the final few feet. 11 minutes and 58 seconds after PDI, the first footpad settles into the lunar soil, and the whole vehicle is stable within 1.5 seconds. Final velocity was a mere 2.3 miles per hour down and 1.16 miles per hour forward. Bean exults, "Good landing, Pete. Outstanding, man," as the crew races through the post-landing procedure. Safing the engine, venting unused propellant, and preparing for potential immediate return. But everything was safe and stable in the ocean of storms. Intrepid would be staying on the surface. One question that may have crossed the mind of both astronauts was why the landing was so dusty. The Apollo 11 crew had warned them to expect some dust, making it difficult at times to pick out details on the surface, but the crew of Intrepid was essentially blind for the last 40 or 50 feet. What was different? Well, a first guess may be that the Apollo 12 landing site was simply more dusty. The crew didn't know this at the time, but that turned out to not be the case. The dust levels and composition were similar enough that it shouldn't have been an issue. How about the fact that the final part of Intrepid's landing was nearly vertical as compared to Eagle's last-minute crater-dodging maneuvers? Or that Intrepid's engine was firing with more thrust? Both of these contributed, but were not the main factor. The biggest difference was something mission controllers were familiar with but did not expect to have such a major impact on the landing: the sun angle. Both missions landed with the sun to their back, but for 12's landing, the sun was 6 degrees lower in the sky. This allowed it to shine through more of the dust, obscuring the ground completely. One consequence of this dusty landing was that from Apollo 13 onwards, the LEM software was modified to allow the astronaut to hand control back to the computer. As you'll recall, P-66 committed the astronaut to a landing. Once you entered manual control, it was all yours. However, in an all-instruments landing, it might make sense to allow the computer to take over again. Some things you just need to learn the hard way. Once the vehicle was safed, and it was apparent that they wouldn't need to leave in a hurry, the crew got to work on EVA preparations. Unlike 11, 12 would perform 2 EVAs, with a rest period sandwiched between them. So the plan was to get outside right away. In an Apollo first, the PINGs and AGS guidance systems were powered down to conserve power during their lengthier stay. A lot of minor things had been changed about the spacecraft and procedures using the lessons learned from 11, but one that made me laugh was the addition of a guard over the circuit breakers. NASA didn't want a repeat of the incident where Neil Armstrong accidentally scraped one of the circuit breaker switches off the wall with his bulky backpack. EVA prep went smoothly, with the crew actually finishing ahead of schedule. Both men credited the high-fidelity EVA prep simulations they practiced on the ground for the trouble-free procedure. Once suited up, the cabin was depressurized and Pete Conrad made his way onto the porch. As he descended the ladder, he activated the live television camera, this time in full living color. It's sometimes funny to think about what technology grew up together. I love the idea that this was a moon landing, but the fact that it was in color TV was notable. As he jumped the last few feet off the ladder and onto the LEM footpad, Conrad uttered what is widely recorded as his first words on the moon. "Whoopee! Man, that may have been a small one for Neil, but that's a long one for me." But since I'm a stickler for such things, I checked the video and the transcript, and his first words on the surface actually came shortly afterwards. First, "I'm going to step off the pad, Mark." And then his first words on the surface were an almost Homer Simpson-esque, "Woo, is that soft and queasy? Hey, that's neat." How the ground can be queasy, I'm not really sure. Pete Conrad got to work outside collecting his contingency sample as Alan Bean made final preparations to head to the surface. What happened next was one of those things that anyone could have seen coming in hindsight, but no one would have predicted ahead of time. Suddenly, several alarms went off in the LEM. Why? This is great. As Bean moved around the cabin taking photos of Conrad, he jostled the vehicle a bit. These small movements caused the LEM hatch to swing almost shut. Then, the sublimated gas coming off of his Pliss backpack pressurized the cabin just enough to first close the door and to then be detected by the LEM environmental control system sensors. Nothing was hazardous, but it was weird enough that the computer raised the alarm and momentarily confused everyone. With that strange moment behind them, Alan Bean made his way to the surface and became the fourth human to set foot on the moon. His first words? "Okay, my, that sun is bright." This crew wasn't one for poetry, it seems. The EVA was planned to be about 3.5 hours long, with an option to extend to 4, but there was no time to waste. The crew had a large number of experiments to deploy, as well as a fancy new color TV to set up. Except, whoops! When the TV camera was being carried from the LEM to its tripod, it was accidentally pointed directly at the sun. The camera sensor was not a fan of that. The image became streaked, then blown out, and finally settled on an inscrutable black and white shape that would not go away. So that was the end of live TV coverage from the moon on Apollo 12. That's definitely not going to help with the public interest thing. Oh well, moving on to experiments. Apollo 11 deployed an early version of the Apollo Lunar Surface Experiments package, but Apollo 12 would be deploying the full LSEP. One experiment making a return was a large foil that was designed to collect solar wind particles. With a lengthier stay, this would be on the surface for nearly 19 hours, as opposed to the 77 minutes seen on Apollo 11. There was also a seismometer, a dust detector, an ion detector, a magnetometer, and a solar wind spectrometer. Some of the findings of these instruments were really weird. Reading about the ion detector, I learned that the moon has ghostly ephemeral clouds of ions that scoot across the surface, influenced by solar conditions. It's too bad they don't glow or something. That'd be pretty cool. Powering all these experiments was a radioisotope thermal generator, or RTG. An RTG uses a radioactive power source to generate electricity by harvesting some of the heat from its decay. It's easy to confuse with something like a nuclear power plant, since it's also using radiation to make electricity, but it's a little different. Basically, imagine a tube full of warm rocks and some equipment to generate a tiny but dependable amount of electricity off of that warmth. That's an RTG. They're often used in situations where solar panels won't work due to distance from the sun or extended stays in darkness. And since these surface experiments were supposed to run for several months and the moon had a 2-week-long night, RTGs made sense. And I guess it worked, since some of the instruments were intentionally shut down 8 years later. The crew ran into a little trouble when extracting the RTG from its transportation cask on the LEM. No problem though, they found that if they repeatedly hit the radioactive device with a hammer, well, it came right out. Let's see a robot do that. That wasn't the only improvisation either. One of the experiments required a large sheet of mylar to be placed on the surface as insulation, but it just wouldn't stay flat in the low lunar gravity. so the crew weighed down the edges with some unused bolts and some scavenged rocks. It's kind of funny to think that on Earth these rocks are super precious, but on the moon it's just like, let's hold this thing down. Throughout the EVA, the crew also collected samples of rocks and dust and a few core samples. Interestingly, they preferred to use the side of the hammer rather than the head since it was easier in the cumbersome spacesuits. Science deployed, rocks collected, and RTGs hammered, the crew piled back into the LEM, with Conrad having spent 3 hours, 56 minutes, and 3 seconds outside. It was time to rest and get ready for the second EVA the next day. The crew reported that contrary to what some feared, a 4-hour EVA was no trouble at all, and they actually could have gone longer. The only real issue was that they could use a way to take a sip of water, if for no other reason than pure oxygen environment was drying out their mouth and throat. But that's easy enough to fix. The next morning, which I'm putting in air quotes since the moon has a 2-week-long day, the crew discovered what was a minor irritation to them, but would be a major hassle for future missions. On Apollo 11, a certain amount of dust was tracked into the LEM, but it was no big deal. On 12, they found that the dust worked its way into the joints and seals of the spacesuits, making it a bit tricky to put the suits back on. Lunar dust tends to stick to stuff, especially on the surface where there are slight electrostatic forces. And since there was no significant erosion on the moon, all of the particles are sharp and jagged. This does not lead to smooth movements in joints and seals. It also doesn't make for happy lungs, but the missions so far have been short enough that that wasn't an issue. The main highlight of the second EVA was a visit to the Surveyor 3 probe, which had been on the surface for about 2.5 years. It was set as the benchmark for landing accuracy, but Conrad actually set it down closer than was planned, just over 500 feet away. The closer landing resulted in significant sandblasting of the probe due to dust being propelled by the LEM rocket engine. This was apparent because when they made their way over there, they could see that the structure was coated in a thin layer of dust, except for the surfaces facing the LEM. Whoops. Once there, the crew removed a few odds and ends, including some cables and the entire TV camera, so scientists on the ground could see how it held up in the harsh environment of space for so long. They also took a number of photographs of the scoops it had dug in the surface so scientists could get a better idea of the robot's performance. They would have taken one more pretty amazing photo here, but alas, some things were just not meant to be. The crew had smuggled a camera timer in with their personal gear and had planned on using it to take a covert lunar selfie alongside Surveyor 3. It would have been an incredible memento, as well as a fun prank for the guys in the photo lab who would have been left wondering how they took the picture. Unfortunately, when the tiny slice of time arrived during which they could have pulled off this stunt, they couldn't find the timer in their equipment bag. Bean spent a bit rustling around, but just couldn't find the thing. Time on the moon is at a premium, the moment had passed, and they soon moved on. It was found later in the mission when it was too late to use, so the crew did the only appropriate thing. Threw it as hard as they could into the distance. Alan Bean, who was a painter, eventually painted what he thought the photo would have looked like. The second EVA drew to a close with more samples collected, a space probe vandalized, and an epic photo op missed. It was time to head home. When Pete Conrad closed the hatch, he had spent 7 hours, 45 minutes, and 18 seconds outside. Quite an improvement on the mere 2.5 hours of Apollo 11. It was time for Conrad and Bean to rejoin Dick Gordon, who had been spending his time busily snapping photos of potential landing sites and even spotting the Intrepid on the surface. Ascent, rendezvous, and docking went smooth as silk as usual, even with a slight overburn by the computer leading to a manual shutdown. Given how easily they've been doing this, it's not hard to forget just how spooked the mission designers of the early 1960s were of lunar orbit rendezvous. The final approach was broadcast live on TV as seen from Yankee Clipper. The TV camera was actually the same one brought on Apollo 11, making that one well-traveled camera. Intrepid had one more trick up its sleeve. After the crew were safely back aboard Yankee Clipper, Intrepid was autonomously steered away to revisit their landing site. Sort of. Intrepid was to crash into the lunar surface about 5 miles from the landing site in order to give the seismograph something to chew on. The engine was a little overzealous, so the impact site ended up being more like 50 miles away, but the seismograph was still able to detect it. Since the crash came in at a very shallow angle pointed roughly at the landing site, I sometimes wonder if any pieces of Intrepid made it back to the descent stage. After 45 trips around the moon, Yankee Clipper fired up its SPS engine for the trans-Earth injection burn, and the crew were on their way home. The trip back was a usual relaxed affair with plenty of TV broadcasts and downtime. Re-entry went smoothly, but splashdown was unusually rough. It turns out the command module was swinging slightly under its parachute and sort of belly flopped at a flatter angle than normal. It had been gone 244 hours, 36 minutes, and 25 seconds, and landed within 2 miles of the target. The crew was again treated to biological isolation procedures, just in case those moon germs turned out to just be hiding last time, but it was decided that face masks were sufficient this time around. Definitely an improvement over the full-body suits. And that was that. America had done it again. There was a little less fanfare and a little less public excitement, but there was a whole lot more time spent on the surface and a lot more science. In fact, the science was just ramping up from there. The crew of the next mission had put more emphasis on collecting a bounty of science than any before. The crew of Apollo 13 was really going to show us something spectacular. Next time, we'll actually hold off on diving into Apollo 13. I'm not sure what it is, but something tells me that it might be time for us to finally pay a visit to Mission Control before we barrel on forward with the next lunar landing flight. Where did this organization come from? How did it evolve from the early days? What was its role in the Apollo missions? And why am I emphasizing it now? After all, it's not like they've had a problem. Ad Astra, catch you on the next pass.